Hello, students. There are two concepts, two questions today based upon one concept, and many more figures can be made like that, which will be based upon the same concept. So, look at the question one. The question is that this block is at a distance L from the pulley, and initially this block is also at a distance L from the pulley, means someone must be holding it. This block ko someone must be holding it so that it is here. And this tabletop is smooth. Now we leave it free. We leave this block free. So the question is what will happen first? यारा ब्लॉक पुली के पास पहुंचेगा या फिर यारा ब्लॉक टेबल को हिट पहले करेगा. राइट, द क्वेश्चन इज यारा ब्लॉक पहले टेबल को हिट करेगा या यारा ब्लॉक पहले यहां पहुंचेगा. You see, the concept of the question is what, and as I told you, this concept could be applied in many more questions. Only there'll be slight variation in the figure. Look at this. Like if we make the FBD of this block, the at any moment, the tension in the string is T. Tension in the string is what? T. This T. So you see, for the left hand side block, T is always towards the pulley. So T will be pulling the block towards the pulley. So displacement L will be covered by what? This tension T. And for here, hitting the table, the vertical displacement should be what? L. For hitting the table, the horizontal displacement has to be what? L, not vertical. The horizontal displacement will be what? It will be L, because it was L distance away. When it hits the table, it will travel a distance L in this side. But now see, at any position, if this angle is theta, then only one component of T will be upwards. That will be T sine theta. And the other component of T will be what? Horizontal. T, this will be T cos theta. And this will be T sine theta. This will be what? It will be T sine theta. So in the horizontal direction, in this case, it's not the total force is not T always. It's what? T sine theta. So obviously, as the theta will change, the T sine theta initially is this. So the theta will change, the T sine theta will also change, right? So the component of T in the horizontal direction, there is only one component of T. So for the horizontal displacement L, only one component of T will be responsible, while here the whole force T will be responsible for the displacement L. So obviously, in this case, the block will reach first. आप बात समझिए ना. इस केस में पूरा टी टेंशन ही इस ओर है, डिस्प्लेसमेंट एल की ओर. और इस केस में डिस्प्लेसमेंट एल आपको जो हॉरिजॉन्टल में चाहिए, उस डायरेक्शन में टी का केवल एक कंपोनेंट है. तो ऑब्वियसली इस ओर का एक्सेलरेशन कम होगा और इस ओर का एक्सेलरेशन ज्यादा होगा. तो यहाँ पे जो राइट लेफ्ट वाला ब्लॉक है, ये पहले पहुंच जाएगा कहाँ पे? एज ऑफ द टेबल, दैट इज ये पुली के पास पहुंच जाएगा पहले. राइट, जो याला ब्लॉक है ये एज ऑफ द टेबल पे पहले पहुंच जाएगा. बिल्कुल सी सिमिलर कॉन्सेप्ट इज बीइंग यूज्ड इन द नेक्स्ट क्वेश्चन. You see, there are two equal masses. There is the same horizontal level. There is the same horizontal level. So obviously they are equal masses. They are in equilibrium. Now this block is suddenly imparted a velocity v naught. इसे suddenly एक velocity v naught. अब बोलोगे कि after some time which mass will be lower. तो देखो यहाँ पे भी क्या हुआ? If you make the FBD after some time, जब ये ब्लॉक यहाँ पहुंच गया, ये तो वर्टिकली ऊपर ही जाएगा. और जब ये ब्लॉक यहाँ पे होगा, सो you see, stream becomes like this after some time. So here see, here vertically upwards is what T, downwards is mg. In this case also, the downward force is always mg. इस केस में भी डाउनवर्ड फोर्स हमेशा क्या है, mg है, बट जो अपवर्ड फोर्स है T का एक कंपोनेंट T cos theta होगा. So which force is decreasing here? The upward force. In this case, upward force is always what? T. That means the net force of downward direction will be more. In which case? In this case. In both the cases, in the downward direction, we are having mg. In this case, in the upward direction, we have T. And in this case, we have only one component of T in the upward direction. That means over a period of time, this block will be at the lower position. So this will be at the lower position. Is that clear? So okay, there's one string, so tension T in both the sides will be what? It will be same. So students, जैसे यहाँ पे मैंने दो figures बनाए हैं, there can be made many more figures. So what you have to watch is जिस ओर के displacement की बात हो रही है, what is the net force in that direction? किस केस में उस ओर का डिस्प्लेसमेंट, उस जिस ओर के डिस्प्लेसमेंट की बात है, उस ओर का फोर्स किस केस में ज्यादा है, ठीक है ना? जिस ओर का डिस्प्लेसमेंट, जिस ओर का नेट फोर्स ज्यादा होगा, उस ओर डिस्प्लेसमेंट जल्दी कवर होगा, राइट? इन द सेम टाइम इट विल ट्रेवल मोर डिस्टेंस in that direction. All right. So you will solve, you'll find many questions which will be based upon this concept only, and you need not to apply any calculations for it. You can directly conclude like this. All right, students.